All right, 10.2 central angles and arcs. There's a lot of ways to call it. But basically that's what we got going on. Very, very important to know how to write things on this. Because again, we're still at the language part of this chapter, which is different from the other chapters. That's close enough. So I want to be very clear about the arcs, because people start getting really confused about arcs. Okay. And right now we're dealing with degrees. Later on we'll deal with like actually the length of it, like in inches, stuff like that. Right now we're just dealing with degrees. So hopefully you figured out a central angle is very simple. It is an angle that starts at the center of the circle. That's why it's called a central angle. We're going to have other angles that we're going to be important, but just remember this one starts at the center. Okay, and I'll do it just like the book basically. Okay, minor arc, major arc, how that works. Okay, a major arc is going to be greater than 180. A minor arc is less than 180. Okay, so there's two ways to look at this angle and two ways to look at these arcs. Okay, that's the minor arc. This is the major arc. Okay, you add them together, it's the complete circle, right? Okay, when we name an arc, I'm going to name this arc, and they put minor arc and major arc in your book. This is how you write an arc. AB. And then I put a little rainbow above it. When I write AB, I'm talking about the minor arc, because I want to go the shortest distance between these 2 points. When I do a major arc, I'm going to put 3 letters in, because this tells me that before I get to B, I have to go through D, right? So I'll go A, D, B. That becomes a major arc. And that hopefully makes sense that a minor arc uses less letters than a major arc. So that's how you should read them. Okay, measuring a minor arc. Well, the minor arc is going to be whatever the central angle is. So the central angle, if it is, let's call this one, it's probably about 60 degrees. That means that this arc is also 60 degrees. What's the major arc going to be? Is it going to be 300 degrees? Yeah. It's going to be 300 degrees because all the way around a circle is 360. And if you add the major arc to the minor arc, you're going to get the whole circle. Does that make sense? Fortunately, we do have the arc addition postulate that says that we can add the 2 arcs together. Okay? No matter what it is, we can add the 2 arcs together. But we always for a major arc, which is above 180, you always put 3 letters. Okay? And of course, a semicircle is half a circle, right? So if you have a diameter, this is a semicircle and it measures 180. Okay. So one thing that we're going to have to do here is we're going to have to know, and it's an application, we're going to have to know about, does anybody remember what these are called? I don't think you've done one of these in a couple years now. It always makes me hungry when I go over them. So it's like a graph. So we're going to call this football. And that's going to be 108 degrees. We're going to call this, basketball. That's 83 degrees. We're going to call this other. 61 degrees. We're going to call this softball. We're going to call this track. What is this called? Pie chart, right? Oh, you can't see it. You got to tell me you can't see stuff, guys. Okay, it's a pie chart. Of course, it's by degrees right here. And so we need to somehow come up with various things. I'm going to put some letters because we're going to treat this like geometry. Okay. So if I had a pie chart like this, what would be the, well, I'll just do this. What do you think the measure of what do you think that's going to equal? I did that in the wrong order. That is incorrect. Now it's in the right order. Of course, I didn't leave room for the arc. The measure of ADE. Of course, you only use 3 letters when it is a major. Right? So I started A, I got to go through D before E. So what is the overall measurement of that ADE? So it's basically, I'm just going to add up this, and this, right? Is it 281? What did you say, 289? 281. 281? Is he right? Okay. And there's actually 2 ways to do it. Since it's all of these, I could just subtract it. So, but let's just do it the right way. 29 plus 108 plus 83 plus 61. 281. Okay. So this is not normally how you do pie graphs, but we can use this to add these up all day long, right? What I want to know about this particular pie graph is what percent of the students or whatever play football. I have degrees. How do I turn degrees into percent? There is some of that, but basically I'm going to use a proportion. So 108 out of how many degrees do you have? Okay, I want to know what percent. What is percent out of? And then you cross multiply, and that's how you get the percentage. That's a P. And again, when I cross multiply now after we did trig, I don't fully cross multiply. I just climb the ladder here and do P equals 100 times 108 divided by 360. Can we do that still? You can do the cross multiplication, but it just involves an extra step. And so whatever you understand at this point, if you don't understand the climbing the ladder, then don't worry about it. It's okay. You do what works for you.
Couldn't you also do 108 divided by 360 and then move the decimal 2 places?
You could also do that. Okay. There's different ways to do it. So no matter what, you're going to get 30%, right? And what she said is to just do the 108 divided by 360. And that's 108 divided by 360. And that's going to equal 0.3, but that's not how you do percent. So you got to move the decimal twice. So then that becomes 30%. So that's another way to do it. Okay. Can I make this hard? Not really. Okay. All right, we had some other theorems, I think. There's got to be something a little bit more difficult. we had the congruent circle theorems. Basically, two circles are congruent if and only if they have the same radius. That makes sense? And congruent central angle theorem. If the same circle, or in a congruent circle, two minor arcs are congruent, then their central angles are congruent. Okay, you got that written down. Similar circles. All circles are similar. Okay? So when it comes to angles and similarity, are angles equal on similar triangles? Same with circles. Angles are equal on circles. So like if I have a circle like this, and a circle like this, and I put an arc like this, and call that like well, let me just go through the book and not get ahead of myself. Okay, let's look at 3 in the book and make sure we can do everything that's here. Name the red minor arc, find its measure. Then name the blue major arc, find its measure. Let's do that real quick. And this shouldn't be super hard. Okay. What's the minor arc called? And the measure of AB is going to be 135, right? What's the major arc called? Nope, I missed. ADB. And what's that going to equal? 360 minus 135. 225. So don't make this hard, guys. And I need to put degrees, so we know it's a degrees. All right, that's fine. That's easy, I hope. 7. Identify the given arc as a major arc, minor arc, or semicircle. Then find its measure of the arc. Okay, BC. That should be easy, right? What is it? Is it a minor? Has 2 letters, it better be. What's the measure? I didn't have to add anything together at all, did I? Let's look at 13 then. What is 13 going to be? It's a major. And probably have to add everything in that journey. So that's almost everything, isn't it? So it's 290?
Can you tell if it's a semicircle?
Semicircle is going to be half, exactly half, or equal to 180. And so do you notice how AC is the diameter? Let's see if I can actually show this. No. Let me look. ABC. Yeah, ABC would be a semicircle. Because ABC, and basically it started on A and ended on C, so it makes it a semicircle. And you can even add up those 2 arcs, 110 plus 70 is 180, so that means it's a semicircle. So good question. So that's basically it on this one. Let me see what I was supposed to assign. I'll turn this off.